Welcome back to the Deep Dive. Our job is to cut through the noise, grab the most critical, complex research, and distill it into a blueprint you can use. Today, we are taking a massive leap into the future workforce, the specialization needed to build and manage truly autonomous systems.
It's a huge topic.
It is.
Wow.
Our focus is on the MCASCE Certified Autonomous Systems and Cloud Engineer Certification, the MCASCE. Now, this isn't just another cloud credential.
Not at all.
It's a detailed 24-month roadmap defining 6 distinct career paths, M1 through M6, that span the entire life cycle of intelligent AI agents. We're going to unpack precisely what skills each level demands and, maybe most compellingly, the staggering financial potential that comes with them.
And what's, absolutely vital for you to understand is the specificity of this certification's goal. It is designed for professionals who have to master the seamless integration of 3 very distinct domains.
Okay, what are they?
We're talking cloud computing, advanced robotics, and intelligent AI agents.
So this isn't simple software development.
Not even close. We're focusing on solutions for industries where failure is just not an option. Think autonomous vehicles, high-efficiency smart manufacturing, and complex industrial IoT deployments. These systems have to be intelligent, they have to be self-governing, and they must be inherently cloud-connected.
That sounds incredibly rigorous, and the program itself, it really reflects that intensity. 24 months with a mandatory month of on-job training and a 2-month final project. It's clearly structured to ensure you're ready to go right out of the gate.
Exactly. And that final project element is crucial. It's the capstone that validates they can take all that theoretical knowledge, say a complex path planning algorithm or a deep learning model, and actually deploy it
into a scalable cloud-native environment.
Right. It moved them from academic theory to, enterprise production readiness.
Okay, let's unpack these 6 levels we'll be diving into. It really is a complete map of the modern autonomous enterprise. We start with M1, the full stack engineer who builds the application, and we scale all the way up to M6, the cloud AI infrastructure engineer.
The one who keeps everything running.
The one who keeps it all running. This structure is what we're going to decode for you piece by piece. So let's start with the big picture of the MCACE credential itself. What gap in the market is this certification explicitly trying to fill?
Well, the primary goal is holistic. It's about equipping learners not just to code, but to architect and deploy autonomous systems that are powered by highly scalable cloud infrastructures.
So it's forcing an integration that didn't really exist before.
Exactly. The previous industry standard often separated robotics engineers from cloud specialists. This program forces them together. This means integrating industry standards like ROS, the robot operating system, which is foundational for a lot of robotics projects, directly with platforms like AWS and deep learning frameworks like TensorFlow or PyTorch. The output isn't a generic app. It's a specialized solution designed for autonomous function, whether that's predictive maintenance in a factory or reliable navigation for a driverless fleet.
Given that ambitious scope, bridging hardware, AI, and cloud, who is the ideal candidate? Do you need a PhD in robotics to even apply?
Not necessarily a PhD, no, but a strong foundation is absolutely mandatory. While it's open to all, priority is strategically given to candidates with a bachelor's in fields like computer science, IT, mathematics, statistics, or economics.
But not exclusively.
No, and that's the important part. They're keenly aware that talent doesn't always come with a specific degree, so they explicitly welcome people who possess strong foundational knowledge in programming and math, whether that expertise was self-taught or from other certifications.
That's a sensible approach, prioritizing genuine skill over a formal pedigree. But the real gatekeeper here seems to be the admission test, the BASR.
The basics of autonomous systems and robotics test, yeah.
I'm curious, why does a cloud engineer need to pass a test that covers robotic kinematics and LiDAR? Isn't that outside the traditional cloud sphere?
That is the defining feature of the MCASCE. It's truly interdisciplinary. The BASR is critical because it ensures every single candidate, regardless of their specialization path, understands the physical constraints of an autonomous system.
The input mechanisms.
Right. The inputs. Take the components of the BASR syllabus. Robotic kinematics, the science of motion, ensures you understand how a robot actually moves in the real world. Then you have sensors and perception covering LiDAR, cameras, IMUs. You have to understand the type, fidelity, and just the sheer volume of data. The cloud infrastructure, the M6 role, will be receiving.
That makes perfect sense. The M6 engineer designing the data ingestion pipeline needs to know that a LiDAR sensor might generate orders of magnitude more raw data than a simple camera feed.
And that dramatically impacts the infrastructure they need to build.
Exactly. Furthermore, the test covers control systems, specifically PID controllers and feedback loops. If your cloud-connected agent is trying to autonomously adjust temperature in a manufacturing plant, you must understand the basic principles of stability.
How not to overshoot the target. Exactly. And finally, path planning algorithms like A-star and RRT are mandatory because those are the calculations the AI agent has to perform to achieve its mission.
So the BASR test acts as a mandatory conceptual bridge. Now let's talk about the economics of this. A 24-month program is a huge commitment, but the fee structure is merit-based. That's a powerful incentive.
Oh, it's highly compelling. The financial structure is designed to reward excellence. If a student gets a score of 90% or above in a semester exam, the fee for their next semester is waived entirely.
Wow.
And even a strong performance, say between 70 and 89%, yields significant fee reductions. This approach ensures they are attracting and retaining the most motivated candidates.
The ones who will ultimately command the highest salaries.
Precisely.
That leads us right to the career multiplier effect. Looking at the data across all these M levels, the financial prospects are clearly defined, particularly in the freelance and remote AI project market.
And here's where the value proposition truly shines. The skills you acquire are so specialized and in such high demand globally that the hourly rates are exceptional. The range starts around $40 an hour, but it escalates fast.
How fast?
It can top out at a staggering $150 per hour for the highly specialized M5 and M6 roles.
$150 an hour, that's a massive figure. That suggests organizations see these professionals as critical, irreplaceable assets.
Absolutely. Their time directly translates into massive operational savings or revenue gains. The other major factor isn't just the rate, but the leadership trajectory. The specialized M levels, particularly M5, the AI architect, and M6, the cloud engineer, explicitly lead towards C-suite roles.
Like CTO or VP.
Exactly. Chief Technology Officer or Vice President positions. And the demand isn't localized. These skills are globally portable, ensuring high earning potential across the US, EU, and APAC markets.
That strong financial outlook, it's not an accident. It's driven by a massive shift in how enterprises are automating their core functions. So let's transition to the why, the explosive growth in autonomous AI agents that is redefining enterprise needs and, shaping the demand for these 6 specialized M-level roles.
The necessity of having 6 distinct specializations is a direct consequence of what we can call the agent advantage in business. We have to move beyond thinking of these as just sophisticated software.
They're quantifiable business tools.
They are. And the most immediate advantage is cost reduction. Enterprises are reporting operational cost reductions from 40% to an astonishing 70%.
40 to 70%.
Right. By automating processes that were repetitive, manual, and, frankly, prone to human error. This isn't marginal savings. This is transformational.
Let's put that into context. How does that 70% reduction actually manifest in the daily life of a company?
Okay, think about a typical IT department. You have people spending hours every day resetting passwords, managing access, filing routine expense reports. An M3 engineered AI agent can handle 70 to 80% of those expense processes autonomously. That frees up the human finance staff to focus on fraud detection or strategic investment analysis. That time gained translates directly to that efficiency gain we see.
But the transformation goes deeper than just savings. The sources talk about a structural workflow shift.
It's a huge shift. Traditional IT systems are inherently reactive. They wait for a server to fail, for a security breach alert, and then they react. AI agents introduce proactive workflows.
Proactive meaning the system is fixing issues before they even become critical.
Exactly. The agent is continuously monitoring the system state, recognizing anomalous patterns, and resolving small issues autonomously. For instance, an agent might detect a slow memory leak on a server and initiate a rolling restart of the service before performance ever drops to a point where a human would notice.
Minimizing downtime.
Fundamentally minimizing downtime. Human intervention is only required for novel or strategic problems.
This shift is often framed as a threat to human jobs, but the materials emphasize the human empowerment aspect.
That's the strategic narrative, and it's an important one. When AI agents handle the routine, frustrating tasks, the constant stream of IT tickets, the tedious data entry, human workers are freed up. Their cognitive load decreases, and their time is repurposed for creative problem solving, strategic planning, things an agent simply cannot manage. This significantly enhances human productivity.
And the measurable ROI is what validates this entire M-level structure. These agents are a clear evolution from, say, simple rule-based chatbots.
Oh, they're a giant leap.
Yeah.
Traditional chatbots rely on rigid rules and scripts. Modern AI agents integrate context perception, complex decision-making, and most importantly, the ability to use external tools.
Like connecting to a CRM or querying a database.
Exactly. They can initiate a purchase order, they can query a financial database, and the ROI reports prove this. We see examples like 43% faster IT incident resolution because the agent diagnoses and implements the fix immediately. In retail, accurate demand forecasting driven by M2 models and executed by M3 agents results in up to 60% fewer stockouts. That's a direct impact on sales.
The moment an AI system goes from just reading a script to actively executing a multi-step plan, that complexity is the root of the necessity for these 6 M levels.
That is the crucial connection. The complexity demands specialization. You need the M1 engineer to build a robust interface. You need the M3 engineer dedicated to MLOps to ensure the agent's logic is reliable.
And you need the M6 engineer to scale the massive cloud infrastructure required to train and host these things.
That's right. And AI-driven development integrates AI into every stage of the software development lifecycle. This requires proficiency in LLMs for reasoning, symbolic reasoning for enforcing rules, and retrieval augmented generation, or RAG, to ensure the agent's knowledge is accurate and current. No single generalist can master all of that.
Okay, that solidifies the why. Now let's get into the structure, the granular details of these 6 specialized roles, starting with M1, the full-stack software engineer. M1 is often your first point of contact with the system. They are the builder of the interface, the application layer that wraps that complex AI engine.
The M1 full-stack software engineer's core mission is twofold: building scalable applications and ensuring they seamlessly integrate the front-end experience with back-end logic and cloud services.
The bridge.
They are the indispensable bridge connecting the sophisticated AI core to the end user.
And the financial prospects really reflect that high foundational demand. Salaries from $80,000 to $120,000, freelance rates $50 to $80 an hour. The industry demand is high, specifically because AI-integrated web apps are now the standard.
They are.
But I imagine the toolkit must be ultra-modern. What are the mandatory skills and tools that distinguish an MCASCE M1 from a general full-stack developer?
The toolkit is optimized for performance and rapid development, which is critical when you're building interfaces for systems that rely on potentially slow-to-calculate AI results. On the front end, mastery of Next.js and React is mandatory. This is built on a strong foundation of HTML5, CSS3, specifically Flexbox and Grid for responsive design and modern JavaScript.
And you mentioned performance.
Crucially, they must master performance auditing. If an AI agent takes 3 seconds to calculate a result, the UI cannot add another 3 seconds loading fonts. The M1 must use Next.js for hybrid rendering and optimization to shave off hundreds of milliseconds.
So saving 200 to 400 milliseconds on a 4G connection just by optimizing assets is a core M1 skill.
It is, and it directly impacts the perceived speed of the AI agent.
Okay, so that's the front end. What anchors the scalable service layer on the back end?
Scalability demands proficiency in RESTful routing using robust frameworks. So that usually means Node.js with Express or Python with Django. Database fluency is mandatory in both relational systems like PostgreSQL and NoSQL systems like MongoDB.
And beyond the code, the M1 has to interact with the operational side, correct?
Yes, the DevOps and Cloud Essentials layer is foundational. M1s must not only write good code, but understand how it gets deployed. Familiarity with CI/CD pipelines, foundational cloud services from AWS or GCP, and tooling like Docker and Terraform are essential.
And the sources also highlight workflow and collaboration practices. What differentiates the M1 engineer's workflow?
It's the mastery of disciplined collaboration. This involves agile practices like daily stand-ups and code reviews, but most importantly, a deep mastery of Git and GitHub workflows. They have to understand concepts like the 3-stage workflow, how to use branching effectively, and how to manage pull requests to maintain high code quality.
Okay, so stepping away from the interface, we move to M2, the data science analyst. This role is all about ensuring the data that feeds the AI is clean, analyzed, and translated into business strategy.
The M2 mission is centered on data processing, robust statistical modeling, and visualization. They are the ones who turn the raw data streams from the autonomous systems into impactful business decisions.
And the market demand for M2 is listed as very high, which reflects that constant hunger for data-driven insights. Compensation is excellent, $90,000 to $130,000 annually, with freelance rates from $40 to $70 an hour.
Their core toolkit is rigorous. Python, leveraging libraries like Pandas and NumPy for wrangling data, and scikit-learn for building baseline predictive models. Strong SQL skills are non-negotiable, and they must be proficient in visualization tools like Tableau or Power BI to communicate their findings.
Knowing the tools is one thing, but the real value of the M2 seems to be translating technical output into business value. What is the statistical minimum they have to master to achieve that?
This is the real difference between a data analyst and a data science analyst. The M2 must be able to translate complex model coefficients into a clear dollar impact for the executive team. They had to turn p-values into clear risk statements.
Quantifying probability.
Right, and they have to convert model error rates into tangible decision buffers for stakeholders. They can't just present metrics, they have to consult on the strategy those metrics inform.
Can you give me a specific example of how an M2 drives measurable gains?
Certainly. In retail, an M2 might analyze transactional data to build a predictive model. Their work drives gains like cutting stockouts by 23% by optimizing demand forecasts. In finance, they can reduce default risk by 15% by creating sophisticated early warning scores. The M2's work directly impacts the bottom line.
Here's where I want to challenge the role a bit. The sources warn that basic reporting tasks are shrinking due to automation. If simpler data tasks are automated, what's the strategic future for the M2?
That's a crucial point. Simple querying and static reporting are indeed being automated. So the M2's future value rests in high-level strategic skills that resist automation. This means mastering causal inference, determining why something happened, not just that it happened. They must excel in sophisticated experiment design, like A/B testing, and provide deep strategic insight consultation.
For our listeners aiming for this path, the sources provided a clear formula for building a successful portfolio that addresses these high-value skills.
Yes, the portfolio formula is an excellent checklist. It requires 3 specific projects. First, a SQL dashboard that uncovers a non-obvious inefficiency in a public dataset. Second, a Python scraper paired with an NLP project analyzing sentiment. And third, a predictive model that is explicitly tied to a measurable business KPI, like predicting customer churn.
That proves both technical skill and business acumen.
Exactly.
Okay, let's transition into M3, the machine learning systems engineer. They move the AI from the data lab into real-world production. This role has critical industry demand, focusing squarely on MLOps and automation.
The M3's core mission is deployment and optimization. They are responsible for ensuring that the ML models are ready for high-performance, resilient production environments. They cover the entire MLOps lifecycle.
And that critical role commands a great salary, $100,000 to $150,000, with freelance rates of $60 to $100 an hour. It reflects the non-negotiable nature of production reliability.
It does.
This role seems to be the critical connector, bridging the research of M4 with the infrastructure of M6. What's their primary focus regarding AI agents?
They are the resilience experts. The M3 focuses intensely on building the systems that ensure AI agents and RAG pipelines are scalable and resilient. If the underlying LLM fails or an external API disconnects, the M3 system has to handle it gracefully.
And that focus brings us immediately to containerization. Why is mastering Docker so essential for the M3?
Docker is non-negotiable because it guarantees immutability. And M3 has to master Dockerfile multi-stage builds to create lean, production-ready images. They must deeply understand the difference between VMs gigabyte size, slow to boot, and containers, which are megabyte sized and start in milliseconds.
Which is key for scaling.
It allows for instantaneous scaling and far higher server utilization, essential for handling unpredictable AI agent load.
So the M3 is defining the agent architecture blueprint itself. What does that blueprint involve?
It's complex. The M3 designs how the large language model integrates with external tool APIs, for instance, connecting the agent to a company's inventory system. They must ensure secure API integration and, critically, implement continuous learning loops so the agents improve over time.
This brings us to a major point from the source material: production hardening. How does an M3 ensure the agent doesn't just crash or make dangerous decisions?
This is the difference between a proof of concept and an enterprise system. The M3 must build resilient agents using specific error handling patterns. This includes wrapping workflow steps with IF nodes to check status codes after every API call. If a failure occurs, they implement Slack alerts and set max retries.
To prevent it from just hanging.
Exactly. And equally important are the guardrails. They must implement a moderation node, which is a gate that scans the user's prompt for PII or harmful content before it ever reaches the LLM. They have to limit tool scopes using dedicated service accounts to ensure the agent has least privilege access.
And audit logging for compliance.
Yes, audit logging for every agent decision, providing a transparent trace for debugging and review. This is how you build a trustworthy agent.
Moving to M4, the deep learning research engineer. This is the cutting edge, the pioneer role. It holds the highest salary ceiling of the technical tracks, reflecting its importance in driving innovation.
The M4's core mission is pure innovation, pioneering advanced neural networks and defining the next generation of AI architectures. They delve into sophisticated structures like CNNs for vision and complex transformer models that power modern LLMs.
And that commands a salary from $120,000 to $180,000, with top freelance rates of $80 to $120 an hour. The demand is cutting edge, dominating AI startups and R&D.
It is.
The M4 is described as a hybrid role, blending deep theoretical research with practical engineering. What does their typical day look like?
Their cycle is structured for constant discovery. It starts with surveying the newest literature, often reading dozens of R6 papers a day, then formulating hypotheses to test. They spend their time coding and experimenting using frameworks like PyTorch or JAX, and then they enter the analysis phase, aiming for state-of-the-art results. This entire process involves managing large-scale, high-cost GPU jobs under strict compute budgets.
They aren't just implementing models, they're inventing them. They need expertise and advanced optimization techniques. The source mentions LoRa, adapters, and depth-wise convolutions. Can you elaborate on why an M4 needs to master a tool like LoRa?
This is where research meets the physical reality of autonomous systems. LoRa, or low-rank adaptation, is a key optimization technique. When you have a massive transformer model, fully retraining it is impossible. LoRa lets the M4 freeze most of the model and only train a small set of added adapter layers. This massively reduces the computational cost of fine-tuning and allows the model to be hardware-friendly. The M4 uses techniques like depth-wise convolutions to create smaller, more efficient models that reduce latency on edge devices.
Like in an autonomous vehicle or a smart factory robot?
Right, where you can't afford network lag. The M4 ensures the cutting-edge model can actually run quickly outside of a massive data center.
I see the link now. But if M4 is focused on R&D, how do they bridge the gap to M3's production needs? Isn't there a risk of building a model that can't actually be deployed?
That's a critical challenge, and it's why the M4 must maintain a practical engineering mindset. Their hybrid nature requires them to anticipate M3's requirements. They write clean, version-controlled code, and they leverage tools like TypeScript for their AI workflows.
TypeScript in research?
Yes. Using TypeScript allows them to type their ML workflows. This means they can catch potential model shape mismatches where the input data doesn't match what the model expects at compile time, not when the model fails in production. It dramatically improves reliability and accelerates prototyping.
Okay, M5, the AI Solutions Architect. This role commands the highest salary ceiling of all the tracks, $130,000 to $200,000, and the top freelance rates. This indicates a role of ultimate strategic importance.
The M5 architect is the ultimate fiduciary. They are defined as the bridge between business vision and scalable AI reality. Their core mission is not to write the code or run the infrastructure, but to design the end-to-end intelligence systems that are perfectly aligned with business objectives.
So if the M5 isn't coding, what is their core value to the organization?
Their value is comprehensive risk management and strategic alignment. They ensure every AI investment solves real business problems, accelerates revenue, and, critically, reduces ethical and security risk. Their job is to take vague C-suite objectives and translate them into a phased, value-driven AI roadmap.
This means their skills must extend far beyond just the technical.
Absolutely. Technical mastery is the baseline fluency in Python, TensorFlow, Cloud AI, MLOps is mandatory. But their career success hinges on business communication. They have to walk into a boardroom and secure buy-in. This means translating accuracy scores into tangible business KPIs.
Explaining how a 98% accurate model reduces liability by a specific dollar amount.
Exactly. They have to justify massive cloud costs and secure user adoption by clearly connecting the AI solution to demonstrable business value.
Given the increasing scrutiny on AI, the M5 is also the champion of designing trustworthy and responsible AI systems, often through the GRC framework.
GRC governance, risk, and compliance. The M5 must institute these frameworks from the ground up. This involves establishing AI governance councils with legal, business, and technical stakeholders. A key action is categorizing models by model risk tiers.
A Tier 1 model being low risk, Tier 4 being critical.
Right. A Tier 4 model, one deciding loan eligibility or autonomous vehicle behavior, has critical risk and requires more rigorous oversight. They must also implement bias testing protocols and strong data privacy guardrails. The future demand heavily favors architects who specialize in responsible AI auditing.
Finally, we arrive at M6, the Cloud AI Infrastructure Engineer. This role focuses on the foundation, the high-efficiency, scalable platform needed to train the models, host the agents, and serve the applications.
The M6 is the architect of scale and efficiency. Their mission is to build and manage scalable, high-performance cloud platforms for massive AI workloads. Industry demand for this role is experiencing a surge, commanding salaries of $100,000 to $160,000 and freelance rates of $70 to $120 an hour.
To master cloud AI infrastructure, you have to first master the fundamental characteristics of cloud computing itself. What are those foundational principles?
They have to understand the 5 essential characteristics. This includes on-demand self-service, broad network access, resource pooling, and the ability to offer measured and elastic services. They need to know that hypervisors are the virtualization technology that underpins all of this.
And this role requires designing and managing a scalable, distributed architecture.
Yes, that includes implementing redundant servers for fault tolerance, using software-defined networking for flexible network configurations, and leveraging distributed storage systems to ensure data durability.
And the undisputed scaling engine for all of this is Kubernetes. The M6 must be a master of container orchestration.
Kubernetes mastery is absolutely non-negotiable for anyone aspiring to the M6 level.
Yeah.
The M6 controls the entire system, the control plane, the cluster's brain, and the worker nodes, the brawn where the containers run.
Let's slow down on Kubernetes. What specific concepts are essential for the M6 to manage these AI workloads?
They need to move beyond simple container knowledge. They have to understand pods, the smallest deployable unit, and the sophisticated workload controllers. They have to master deployments, which are critical for application updates, allowing for zero downtime rolling updates.
And rollbacks.
And safe rollbacks, yes.
Yeah.
But for AI, they must also master stateful sets. Deployments are great for stateless apps, but stateful sets are vital for systems like databases or complex ML models serving endpoints that require stable, predictable storage and network identity.
And finally, managing cloud cost and performance requires a closed-loop auto-scaling system. How does the M6 implement that?
They implement a closed-loop system for continuous monitoring and auto-scaling. This involves integrating the metric server to gather real-time performance data. That data feeds into the horizontal pod autoscaler, or HPA, which scales the number of pods based on metrics like CPU use.
And what happens when you run out of room?
When the HPA runs out of room on the existing nodes, the cluster autoscaler is activated. This tool scales the underlying nodes, the actual virtual machines, ensuring the platform maintains performance and, critically, optimizes cloud costs in real time. The M6 is the efficiency and reliability expert. So now that we've covered the 6 unique specializations, we had to pivot to the essential non-specialized skills required universally across all M levels. To ensure successful collaboration, every engineer needs a strong, common technical foundation.
Okay, let's unpack this mandatory code foundation, starting with Python and JavaScript. They seem to dominate the ecosystem.
They are the dual pillars. Python is absolutely essential for data-centric roles like M2 and M4, but also for automation. It's valued not just for its libraries like Pandas and NumPy, but for its readability. It accelerates collaboration.
And JavaScript, traditionally a front-end language, has secured its spot as essential across the M levels due to Node.js, right?
Precisely. JavaScript powers 98% of the web, making it critical for the M1 full-stack engineer. But Node.js provides full-stack capability, allowing the M1 to use a single language for both front-end and server-side development.
Streamlining the whole process.
Exactly. All M levels must be fluent in modern ES6+ features and asynchronous programming using promises and async await, which are essential for handling cloud API calls.
Moving from programming to data access, in a world with vector databases and data lakes, SQL still seems to be king for the MCASCE professionals. Why?
SQL remains the universally adopted standard for interacting with relational databases, which still hold the majority of sensitive, structured enterprise data. Even if an AI agent is querying a vector database, the grounding data often starts in a relational SQL system.
So they need to know all three statement families.
DML for manipulating data, DDL for defining structures, and DQL for querying data.
What are the core skills that separate a competent user from an M-level master?
Mastery goes beyond simple select statements. It requires fluency in select, from, and where, and an expert grasp of power features like group by for aggregation, and most crucially, mastery of joins inner, left, right, and full to unite related tables and extract complex insights.
If the AI agent is the worker, then APIs are the communication highways.
Correct. RESTful APIs are the standardized communication method for integrating agents and microservices. All candidates must understand the core concept of the resource as the centerpiece and the strict semantics of HTTP verbs get, post, put, delete.
And when communicating across these systems, security is paramount. That means robust identity proofing via authentication.
Authentication is the gatekeeper. The M levels must understand modern protocols, including cutting-edge methods like FIDO2 and WebAuthn, which create unphishable, passwordless futures.
A key technology for autonomous vehicles or factory floor access.
It is. They must also be fluent in enterprise standards. SAML, OAuth 2.0, and OpenID Connect. These are essential for single sign-on. The M3 engineer must ensure that when an agent accesses a tool API, it is using a tightly scoped OAuth token, providing least privilege access.
This has been an incredibly detailed and necessary exploration, mapping out the precise architecture of the future tech workforce. We've covered the entire breadth of knowledge required by the MCASCE certification, structuring this complex landscape into 6 clear, high-value pathways.
We saw how every role, from M1's front-end polish to M6's Kubernetes efficiency, must support the ultimate goal: the highly efficient, scalable, and trustworthy autonomous AI agent. The evolution from simple chatbots to autonomous workers that leverage deep reasoning and secure tool usage is what drives the massive demand for these specialized, high-paying roles.
The future of the autonomous enterprise really relies on this multi-agent collaboration.
And the seamless orchestration of end-to-end processes and robust governance, risk, and compliance frameworks. These 6 pathways are designed not just to build these systems, but to govern their behavior.
So what does this all mean for the person listening right now, maybe considering one of these 6 career paths?
The rise of AI-driven development and autonomous agents raises a profound question regarding the human factor, a question we have to confront head-on. While agents take over increasingly complex tasks, there is a risk of domain skill atrophy in human experts.
They might start to passively accept AI recommendations
without applying critical thinking or verifying the underlying logic. And this leads to our final question for you. What human-in-the-loop, or HITL, processes do you think are most crucial to preserving domain expertise as AI takes over more complex workflows? Should we mandate human approval for every high-risk decision, even if it slows things down? Or is it more crucial to focus on maintaining extremely transparent reasoning traces that force human experts to actively review the AI's logic, thereby keeping their skills sharp? The answer determines whether we truly become augmented experts or, merely passive recipients of autonomous output.
A compelling challenge to leave you with. As the technology speeds forward, the responsibility for critical thought and robust oversight rests, as always, with us. Thank you for joining us for the deep dive. We'll see you next time.